So this is all found on page 75. And you have written the conditional on your paper. The conditional is an if-then statement. Starts with the word if, has the word then, has two ideas in there. You've written it down. If two angles have the same measure, then they are congruent. Do you believe that's true? You believe that's true? Okay, so I want you to write true right there. Yes, I think that's true. Next, I want you to identify the hypothesis. It's real easy. The hypothesis is the idea that comes behind the word if. So I want you to circle, and I want you to write hypothesis right there. That's your hypothesis. Y'all, sometimes your book will refer to that as P. The idea, the hypothesis, the phrase, the statement, they'll call it P. Alright? So be prepared for that. You don't have to call it P, but if they call it P, I want you to know what they're talking about. The next thing we need to do is identify the conclusion. There's your conclusion. And sometimes your book will call that Q. All of this is a review from 2.1. Okay? The next thing we need to do is we need to write the converse. The converse is where you switch the hypothesis and the conclusion. You just switch those two items. It also starts with the word if, so you write if two angles are congruent, then they have the same measure. And I'm going to color code it. That's my hypothesis. Where does it end up in the bottom? Here. Okay, the hypothesis comes second. Can you see it? I can't really see it, can you? Where's the conclusion here? It says they are congruent. They are congruent. So they're switched. You switch the hypothesis and the conclusion. Now, I want you to tell me, do you believe that the converse is true? Read the statement, back up from it. There's two pieces to that. One piece is getting the phrase in the right spot. Then you step away and you decide if that sentence you formed is true or false. If two angles are congruent, then they have the same measure. Is that true? Do you believe it's true? Can you find a and how do you prove it's false? You only have to have one example of it not working for it to be false. But I can't find any for this one, so this one's also true. Okay, so that's all lesson 1. Lesson 2 today says, hey, guess what? If both of those statements are true, then you can write it as a biconditional. Okay, so that's what we're going to do today. We're going to write it as a biconditional because the conditional was true and the converse is true. The biconditional will say, and here's what you do. You write the pink part, and then you put if and only if, the blue part. The pink part, the blue part. That's how you form a biconditional. So you say, two angles have the same measure if and only if they are congruent. Okay? So biconditional is our new item for today, and that's how you form that. Now, if you'd written the converse and it had turned out to be false, you couldn't write a biconditional. Is that what you were going to ask me?
I was going to ask you, but I use the written from the converse or the conditional. So, like the pink part, is that the pink part with the conditional?
Yes. Well, it should be the same. Have the same measure as the pink part throughout the whole thing.
I got it.
Okay? I should be color coding it in a way that it stays. Okay? Keywords are congruent. Congruent should always be in blue for this one. Now, if they started out the other way around, we'd color code it different. But I want you to follow where that pink goes all the way through. So your hypothesis, sometimes when you write the converse, your hypothesis ends up at the end of the statement. Okay? If they say, hey, I'm giving you a conditional, then you know the first idea is your hypothesis. Okay. If this was true and this was false, you could not write this. If this was false and this was true, you could not write this. You can only write this when both directions are true. Here's how your book illustrates it. They say, the first one they write as if P, then Q. That's how they write it. The second one they write if Q, then P. And then this one, they write this P double-sided arrow Q, meaning it doesn't matter which piece of information I give you, you know the other piece has to be true as well. Okay? Another example that your book has, you do not have to write this example down because I know y'all get tired of writing, but another example. If 3 points are collinear, then they lie on the same line. This is the conditional. I want you to identify the hypothesis. What's the hypothesis? Okay. What's the conclusion? Okay. Do you believe it's true? Yes. All right, let's write the converse. I'm going to write it, and you know my handwriting. So what are we going to say first?
3 points lie on the same line.
Okay, so collinear is the pink idea. Lie on the same line as the blue idea. Do you believe this statement's true? Yes? So write a biconditional. Now, what do you start with for your biconditional? You got to start with pink. Okay, 3 points are collinear if and only if they lie on the same line. Okay, questions on that? Can y'all handle that? Now, I only gave examples where it works. You know sometimes it's not going to work, right? Okay. Example 2. Write this on your paper. Okay. Sorry. A number is divisible by 3 if and only if the sum of the digits is divisible by 3. Write that on your paper. So I'm giving you the biconditional. We're going to have to work backwards. You know that's how it always works in here. We do this, and then we turn around and say, okay, now what if we went backwards? So write that on your paper. It says, a number is divisible by 3 if and only if the sum of the digits is divisible by 3. The first thing we're going to have to do is identify the hypothesis and the conclusion. So when we write biconditional, the hypothesis, we've been colored at what color? Pink. Okay? The letter we use to represent it is pink. So what do you think is the hypothesis in this statement? Okay. And what's the conclusion? Okay. So, can you write the original conditional for me from this? If you know the hypothesis and the conclusion, can you write the conditional? And can you write the converse? How do you write the conditional? What would it say? And how would you write the converse? What would the converse say?
The sum of the digits is divisible by 9.
Mm-hmm. Okay. Everybody good on that? Can you do those? You got the pink and the blue stuff going on, right? There's pink. There's blue, and then there's blue, and then pink. Okay. I want you to look with me at the bottom of the page, page 76. Your job is the bottom of 76. It looks like the under the seat. It looks like you're in the fish tank or something. Your job is to write a definition for
Polyglob.
a polyglob. Yeah, you're gonna have to. And they show you. What do they show you over to the side? They show you what polyglobs are, and then they show you what polyglobs are not. So you got to study those. Sometimes a good definition, a good way to learn something is to look at what doesn't fall into that category. So your job is to write a definition for polyglob. You need to talk with your partner about that. It'll be about a minute and a half, because this is not going to take long. So if you need to talk to your neighbor about it, go ahead. turn to your neighbor and tell them what a polyglob is. Tell them your definition, and then they're going to tell you theirs. And what you're listening for is to see if you agree or not. Okay? So have this conversation with somebody. Three what? What do you think, Adam? You want to talk about polyglob? You quit talking about last week? You quit talking about polyglob first week? No, neither did I. That's what we're supposed to find out. Yeah. What do these things have in common? How many fingers have you got?
Oh my.
How many how come this one's not? Is it checking that one?
Oh.
Oh, it's just three of them. What's wrong with Okay, somebody share with me their definition.
Adam will.
Okay, thank you, Haley. Let's listen to her. She says polyglobs have
3 legs and 3 black eyes.
3 legs and 3 black eyes. Did anybody get anything different? Okay, John, what did you get?
I have one.
Hello.
I have one. They are the jellyfish of math.
There you go, the jellyfish and math. John, come on, share it with us.
Okay, it's a microorganism that lives in the deep sea and it produces its energy by using photosynthesis, which is the first of many metabolic processes which converts sun energy into glucose.
Do you bring your son anything here with you?
No, Miss Pearson will be tickled. See, look, hey, when you get to be in this grade, you're gonna be talking like that. It's gonna be great. Okay. Now, let me ask you this. Creativity, yes. Very creative. But let me ask you, now listen up. If I told you that I would give you a prize if you could pick out the other polyglot in the picture, which definition is going to get you that prize?
I didn't finish.
Oh, I'm sorry. Okay.
No.
Continue. Did you say it has 3 tentacles and 3 black eyes?
Actually, Jonathan might be right though, because it has photosynthesis as chlorophyll, and then polyglob's green in there.
What do you think it makes polyglot? What's poly mean? Knitting. Poly means knitting. Do you think that after, okay, the definition Haley gave is probably the one everybody came up with, 3 tentacles and 3 black eyes. So, since it has 3, then maybe we could call it a triglob?
Maybe.
Okay. So what's the other polyglob in the picture? B. B. What's wrong with A?
It has 2 eyes, not 3.
Okay, what's wrong with C? Okay. I hate to break it to you, but we're not studying polyglobs, and we're not studying things like that. What we're studying is how to write a good definition. Look with me on page 77 of your textbook. A good definition uses clearly understood terms. The terms should be commonly understood and already defined. A good definition is precise. Good definitions avoid words such as large, sort of, and some. A good definition is reversible. It means you can write a good definition as a true biconditional. Show that the definition of perpendicular lines is reversible, then write it as a true biconditional. We're going to look in our book for this. It says perpendicular lines are 2 lines that intersect to form right angles. If you wrote that as a conditional, you would write that as, if two lines are perpendicular, then they intersect to form right angles. And its converse would be, if two lines intersect to form right angles, then they are perpendicular. The two conditionals, the converses of each other, are true, so the definition can be written as a true biconditional. Two lines are perpendicular if and only if they intersect to form right angles. Okay? You can do this. It's the same thing we've been doing. Let's talk about down here. Is the statement a good definition? Explain. You have to look in your book. I know it's blurry up here on the board, but it says an airplane is a vehicle that flies. Do you believe an airplane is a vehicle that flies? Yes. Is that a good definition? Because a good definition won't lead you astray. There won't be anything else that falls into that category. Like if I said, if it's an airplane, then it's a vehicle that flies. True?
It's true, but
If
that,
it's a, what were you going to say?
but that kind of definition is for news.
Oh, okay. Well, listen to this question. If it's a vehicle that flies, then it's an airplane. Oh, okay.
There's enough.
So that's not a good definition, because when I reverse it, you can find fault in it. Okay? When you reverse it, you can find, okay.
It's not the only thing that can fly.
That's
And this
right.
definition is for pros. There are other vehicles that can fly other than just that. Like a hang glider, and a helicopter, a rocket ship, and...
Let's move on. We're not studying aerospace travel. A triangle has sharp corners. Do you believe that to be true? So if I said, if it's a triangle, then it has sharp corners. That's okay, yeah. But what if you reversed it? If it has sharp corners, then it's a triangle.
Every other circle in the universe except for circles.
So you're to
Every other circle.
every other shape. So what do you mean? You knew that. Now listen, y'all. I'm not opening this can of worms so we can debate polygons or air travel. We're talking about whether something makes a good definition or not. If you can reverse it, and it's also true beyond the shadow of doubt, then it's a good definition. If you reverse it and you can find fault in it, it is not a good definition. That's the whole point. A square is a figure with four right angles. Do you believe that to be true? A figure with four right angles is a square.
No, because it's got rectangles.
Okay. So here we go. It's time for you to practice this on your own. Page 78. 1 through 23 all on page 78.